This module here provides two PWM waveforms that are going to be used to control the angle of the camera gimbal, and also to provide simulated signal that will be representing the angle of the platform with respect to the horizon. Okay. The two waveforms can be seen on the oscilloscope. Top trace, which I've synchronized at the moment, is showing the angle of the gimbal, and I'm varying it between 1 millisecond and the full 2 milliseconds. The waveform below, which you can actually see, is asynchronous, which is representing the angle of the platform. If I just space out the time base a little bit, we can see a little bit clearly what's actually going on. Okay, you can see clearly that the two waveforms are asynchronous. Okay, moving down to the actual rig that we've got. Okay, what we've got here is the actual simulator, if you like, or the generator generating the two waveforms. The two waveforms are then fed into the mixer module, and the mixer module, as before, was driving the servo for the angle of the camera gimbal. I'm just rotating it about at the moment. Pull back a little bit. Now we're demonstrating there, we can set the angle like we did before of the camera gimbal itself. Okay, so we'll set that down to a vertical position, and then what we'll do is we'll rotate the platform 45 degrees in one direction, and then we'll bring the platform back down into the opposite direction. Okay, and then back to the center again. Now, if we turn the camera gimbal to its extreme position, which is plus or minus 45 degrees of the center, and if we rotate the platform up, then obviously there's only so far you can go, and obviously now we've reached the camera gimbal with respect to the platform is now 90 degrees. Obviously, if we then rotate the platform back to the horizontal and continue to rotate in the opposite direction, the camera can't rotate any further, so it stays at its extreme position all the way up to the other side. And if we bring the actual camera up to perpendicular and demonstrate it in the opposite way, you can see now that the platform behaves in the same manner. I've overcome this problem with the wraparound effect, and by just a simple correction to formula to generate the differential angle. I've now sort of fixed that problem. The response time with this version of the build isn't quite as good as the previous one. There still is a little bit of shudder. That shudder's down to the resolution that I've set on the generator module. I could actually increase the resolution, so the actual step size of the position is what's causing the shake to the platform. Again, this is sort of areas that can actually be improved upon, and just demonstrating there is a slight little bit of a lag between if we actually sort of move it quite fast, the actual settling time is quite slow compared to the previous version. Just having a little look at the waveforms, if we now bring up the third waveform, I'm going to bring on the third waveform, just reduce the resolution of these, the amplitude and the sensitivity of the scope. So the top waveform is the platform angle, the second waveform is the middle waveform rather, is the set point for the camera gimbal, and the waveform at the bottom, as you can see, is the signal that has been fed to the corrective signal, which is fed to the camera gimbal, and that's the output or the product of the mixer process. So if we just alter the actual time base there, you can see that all three waveforms are totally asynchronous, and so during all phases, relative phases, that the platform continues to respond. Like I say, there is a slight downside this time with the processing overhead. is a little bit slow, a bit sluggish to correct, but you can see that it's just a little bit slow to correct, and we'll just bring up and that's just exceeding the actual, it's actually going further than the 45 degrees. So the normal 45 degree angle obviously the greatest range is when the gimbal's central, in the central position. I think that just about does it.